All right, let's do this. You wanted us to take a deep dive into design patterns, and well, you really came through with some awesome material, excerpts from Headfirst Design Patterns. This book is awesome.
Yeah, it really lives up to all the hype. Even Eric Gamma, one of the authors of the original Design Patterns book, said he loved it.
Wow, that's high praise coming from him.
Right.
Not just the content either, like the way it's written.
Oh, yeah.
The authors, Eric Freeman and Elizabeth Robson, really know how to make complex ideas fun and
Definitely.
engaging. And then
Yeah.
they've got Burt Bates, who's like a super serious Go player.
Really?
Yeah, in his spare time.
Oh, that's cool.
It's like, what? So, okay, let's get down to business. The book tackles this like huge challenge we all face as software developers.
Okay.
How do you make systems that can like gracefully adapt to change, right? Because things are always changing.
Oh, for sure.
And our designs need to be flexible enough to roll with those punches. So they use this really clever analogy of a simu-duck application, right? Where they try to model all these different duck behaviors, but using inheritance.
Uh-huh.
And it quickly becomes a mess as they try to add more and more types of ducks.
Yeah, inheritance can be tricky like that. You start with good intentions,
Right.
but it can get pretty messy.
Yeah, like you end up with these rigid designs that are like impossible to change.
Exactly. It's like trying to fit square pegs into round holes.
Totally. And that's where this key principle comes in.
Well-
Encapsulate what varies. It's about identifying those parts of your code that are most likely to change and like isolating them so you can modify them easily
Right.
without messing up the rest of the system.
Exactly. You got to separate what changes from what stays the same.
Makes sense. So this leads us to one of the the most important principles in software design,
Oh, yeah.
the open-closed principle. Have you heard of this?
I have it.
The idea is that design should be open for extension but closed for modification, meaning you should be able to add new features without like ripping apart your existing code.
Right. So you're extending the functionality without modifying the core.
Exactly. It's all about future-proofing your designs, right?
Absolutely. It's a game changer.
And the book gives us a whole bunch of design patterns that can help us do just that.
Yeah.
It's like having this toolbox full of, proven solutions to these common design problems.
I like that analogy, the toolbox.
Yeah. So are you ready to open up that toolbox?
I'm ready. Let's do it.
Okay, the first pattern they dive into is the observable pattern.
Okay.
They use this weather station example where you've got all these different displays that need to be updated whenever the weather data changes.
Right. Classic example.
So instead of the weather data, like having to know about all the different displays and how to update them, individually,
Yeah.
it just sends out a notification and any display that's interested can just subscribe to those updates.
Exactly. It's all about decoupling the subject from its observers, which
Yep.
are the display elements in this case.
Right, decoupling.
That's really the key here. It makes the whole design so much more flexible.
Yeah, because you can add new displays without like rewriting the weather data logic, or
Right.
you could even change how the weather data notifies its observers without messing with the displays.
Precisely. It's incredibly powerful, especially when you're dealing with systems that need to evolve over time.
Yeah. So they also mentioned different ways to implement the observer pattern, like push versus pull models for data transfer. Ever worked with those?
Yeah, for sure.
It's a trade-off, right?
Absolutely. It depends on, things like how often the updates happen and how much data you're moving around.
Right.
You got to weigh those factors.
Definitely something to explore further.
Hmm.
Okay, next up is the decorator pattern.
Okay.
I love how they use this example of customizing coffee orders at like a coffee shop, Starbucks, to explain it.
Yeah, that's a good one.
You start with your basic coffee and then you add on all these extras like
Yeah.
milk or soy or mocha, whipped cream, all that stuff. And each addition changes the price.
So it's like dynamically adding responsibilities to an object.
Exactly. Instead of creating a subclass for every possible combination of, coffee additions,
Yeah.
you just wrap the basic coffee object with these decorators that represent each addition.
I see. So it's like you're building your own custom coffee creation.
Yeah, exactly. And this ties in nicely with the open-closed principle, right?
How so?
Well, you're extending the functionality without modifying that original coffee class.
Oh, I see what you mean. You're adding on to it, not changing the core.
Right. Okay, so we've seen how to decouple objects with the observer
Uh-huh.
and how to dynamically add functionality with decorator.
Yep.
Now let's talk about creating objects themselves
Okay.
with the factory pattern.
And factory pattern.
They use the example of different types of pizzas to illustrate this one.
Pizza, who doesn't love pizza?
Right, it's a classic. So the idea is that instead of, directly creating objects with like the new keyword,
Right.
you use a factory to create them for you.
Right, so it's like a specialized object creation machine.
Yeah, and it decouples your clients from those concrete implementations,
I see.
which can be really useful when you're dealing with like families of related objects.
Right.
Like in the pizza example, you've got all these different types of pizzas,
Right.
but you don't want your code to be tied to those specific pizza classes.
That makes sense. So the factory handles all that for you.
Exactly. And they walk us through like three main types of factory patterns, right? You've got your simple factory, factory method, and abstract factory.
No, that's a lot of factories.
Right. And I'm already wondering, like, when do you use which one?
Yeah, that's a good question.
Seems like there's a lot to unpack there.
Definitely. It's a whole other deep dive just on factories.
Right. Okay, let's move on to the singleton pattern. This one I think is pretty straightforward. It's like you want to make sure that a class has only one instance.
Right, one and only one.
And you provide a global access point to that single instance.
Okay.
So like think of things like database connections or configuration settings.
Yeah, you don't want multiple instances of those running around.
Right. You need to make sure there's only one. And the book goes into some different ways to implement singleton, but the main takeaway for me is sometimes you just need one of something and you need to make sure there's only one.
Absolutely, makes sense.
But is there a downside to using singleton?
Oh, there can be. Sometimes people overuse them.
Okay.
And it can lead to some tight coupling in your code and can actually create some design issues.
Yeah, I guess that makes sense.
It's like any tool.
Yeah.
You got to use it the right way.
Right, right.
Otherwise, you can cause more problems than you solve.
Okay, good to know. Moving on. We come to the adapter and facade patterns.
Okay.
These sound like they could be like superhero names.
They do, don't they?
The adapter pattern is all about, converting the interface of one class into another interface that, the clients are expecting.
Right.
So it lets classes work together that, couldn't otherwise because their interfaces just don't match up.
It's like a translator for your code.
Yeah, exactly. Like the book uses this analogy of an AC power adapter. It takes the electricity from the wall outlet and converts it to something your device can use.
I see. So it bridges the gap.
Right. And then you've got the facade pattern, which provides a simplified interface to this complex subsystem.
Okay.
So it makes it easier to use by hiding all the messy details behind this nice, clean interface.
So it's like a concierge for your code.
Yes. That's a great way to put it.
You just tell the facade what you want, and it takes care of all the details behind the scenes.
Exactly. And speaking of taking care of details, let's talk about the template method pattern.
Okay, the template method pattern. Let's hear it.
This one, they use this relatable example of preparing types of caffeinated beverages.
Okay, so we're back to coffee again.
Right. It's like you have this basic recipe, but you can customize certain steps, like how you brew the coffee or what kind of condiments you add.
Right, so it's all about providing a structure while still allowing for variations.
Exactly. The template method defines the skeleton of an algorithm in a method, and then, it defers some steps to subclasses.
Okay.
Which allows you to, redefine certain steps without changing the overall structure.
So you're saying it's like a blueprint for an algorithm, but with some flexibility built in.
Yeah. And that's all we have time for in this part of the deep dive.
Oh, already.
I know, right? We've covered so much ground, but there's still so much more to explore. We've got a whole toolbox full of design patterns just waiting to be opened. So, I guess we'll pick this up in part 2. You up for more design pattern fun?
Absolutely. Let's keep this deep dive going.
All right, we'll see you there. All right, I'm back and ready for more design pattern action. Last time we left off talking about the SimUduck app, and they threw in this new requirement, right? Grouping ducks into flocks.
Ah, yeah, I remember that.
Sounds like that could get messy. Like, how do you manage all those ducks?
Well, that's where the composite pattern comes in handy.
Okay, tell me more.
So it helps represent these part-whole hierarchies, like flocks of ducks.
Okay.
And it lets you treat individual objects, like a single duck, and a group of objects, like a flock, the same way.
Whoa, so I could write code that interacts with one duck the same way it interacts with a whole flock of ducks.
Yeah, exactly.
That's pretty powerful.
Right. It can make things a lot simpler when you're dealing with those kinds of relationships.
Definitely. It's like a flock of ducks flying in formation, right? They move as one.
That's a great analogy.
I'm full of them today. Okay, so we've got composite for managing these hierarchies. Oh, and they bring up the iterator pattern again here.
The iterator pattern, yeah.
Yeah, remember we talked about that earlier?
Yeah, briefly.
Iterators provide a way to, like, loop through a collection of objects without having to know how that collection is actually stored.
Right, like going through a list without worrying about whether it's an array or a linked list underneath.
Exactly. And they suggest using iterator and composite together for, like, traversing those complex structures, like trees.
Oh, yeah, that makes
So
sense.
you could, visit each duck in the flock no matter how they're organized.
Exactly. That's a great use case for combining those two patterns.
Awesome. Okay, moving on. We've got the state pattern. I remember this one from the gumball machine example.
Ah, yeah, the gumball
It
machine.
was all about managing the different states an object can be in, right?
You got it. The state pattern basically encapsulates those different states and delegates the behavior to the current state.
Okay, so instead of having this massive if-else block checking for all the possible states of the gumball machine,
Right.
each state gets its own class, and the machine just delegates to the right one.
Exactly. Keeps your code a lot cleaner and easier to manage.
Yeah, especially when you have a lot of states to deal with.
For sure.
Oh, and they mentioned a similarity between state and strategy. I'm a little fuzzy on that. How are they different?
Well, they might look similar at first glance,
Uh-huh.
but the key difference is really their intent. With strategy, you're giving the client the power to choose between different algorithms at runtime.
So it's like, I have a toolbox of algorithms, and I can pick the right tool for the job.
Yeah, exactly.
But with state, the object itself decides which state to transition to based on its own logic.
Right, the client doesn't need to know about the specific states.
So state is more about the object's internal behavior, and strategy is more about giving the client choices.
Precisely.
Gotcha. All right, let's move on to the proxy pattern. If I remember correctly, it was about controlling access to an object.
That's right. The proxy pattern provides basically a surrogate or a placeholder for another object to control how you access it.
Like that example with the placeholder image while the real image loads.
Yeah, that's a classic use case for a proxy.
But there are other uses too, right? Like security checks or remote method calls.
Oh, yeah, lots of different applications.
And they said proxy and decorator can be confused, and I get that. They both wrap an object, right?
Yeah, but the difference is in their purpose.
Okay.
Decorator adds responsibilities, while proxy controls access.
So decorator is like giving the object superpowers,
Uh-huh.
and proxy is like a bouncer at a club.
That's one way to think about it.
Nice. Okay, last topic we got to cover. Compound patterns. What are those?
So compound patterns are basically combinations of multiple patterns used together to solve more complex problems.
Ah, I see.
Like a great example is the MVC pattern.
Oh, yeah, MVC, Model View Controller.
You know,
It's like a staple of web development.
It is. It's everywhere.
It separates the application into three parts, right?
Right.
The model, the view, and the controller.
Right. Model handles the data and logic. View is the user interface. And controller manages the interaction between them.
Yeah, and MVC actually uses other patterns under the hood.
It does. It does.
Like observer and strategy, depending on how it's implemented.
Yep. It's a team effort.
It's like a design pattern all-star team.
Exactly. And
Yeah.
the book actually talks about a specific MVC implementation called Model 2.
Model 2.
Yeah, it's specifically for web applications. You know, it uses things like servlets and JSPs.
So Model 2 takes those core MVC principles and applies them to the world of web development.
Right. It's a way to structure web apps using MVC.
This is blowing my mind how these patterns have evolved to address these specific challenges.
Yeah, it's pretty cool, right?
It's like they have a life of their own.
They do, in a way.
And speaking of life, it feels like we need to take a break and recharge before we finish this deep dive.
Yeah, we've covered a lot of ground.
I'm already looking forward to part 3. We'll wrap up this design pattern adventure and see what new insights we can uncover. See you there. Okay, we're back, and I'm still processing all this design pattern goodness. It's like my brain is doing a little refactoring.
Yeah, there's a lot to take in.
It is, but it's so cool. It's like we've been given this new way of thinking about design.
Definitely. It changes your whole perspective.
Wait, last time we were geeking out over compound patterns, right? Like those combos of individual patterns working together to solve bigger problems.
I like MVC.
Exactly, MVC. Does the book talk about any specific MVC implementations?
It does. They touch on something called Model 2,
A Model 2.
which is It's specifically for web applications.
Okay, so it takes the core MVC principles and applies them to like the world of web development.
Yeah, like, dealing with user requests and generating HTML and all that stuff.
So it brings in things like servlets and Java server pages.
Exactly. It formalizes those roles.
Wow, it's amazing how these patterns, like, they've evolved to address these specific challenges in different areas of software development.
Yeah, it's like natural selection for design patterns.
I love that. But I gotta ask, are there any patterns that we haven't covered? Like, I know head-first design patterns is pretty comprehensive, but, software design is a huge field.
Yeah, there's always more to learn. They do mention a few leftover patterns in an appendix.
Leftover patterns, that sounds intriguing. What are some of those?
Well, there's the bridge pattern, which lets you vary both the implementation and the abstraction of an object independently.
So it's like creating a bridge between two different class hierarchies.
That's a good way to think about it. Then there's the builder pattern, which gives you a step-by-step way to build complex objects.
Like an assembly line for objects.
Exactly. And we can't forget the chain of responsibility pattern that lets you pass a request along a chain of objects until one of them handles it.
These leftover patterns sound just as cool as the ones we've already talked about.
They each have their own unique strengths.
It's like this whole universe of design patterns just waiting to be explored.
It is, and the more you learn, the more you realize how much more there is to learn.
So as we wrap up this deep dive, what's like the one key takeaway you want our listeners to remember as they go forth and conquer their own design challenges?
I'd say just remember that design patterns are tools, not rules.
Okay, tools, not rules.
They're there to help you, but you don't have to use them for everything. Sometimes the simplest solution is the best solution, even if it doesn't involve a fancy design pattern.
Right, don't overcomplicate things.
Exactly. Use your judgment and always be willing to learn and adapt.
I think this deep dive has given us like a whole new arsenal of tools and ideas
You too.
and a new appreciation for the power of good design.
Absolutely. Good design is the foundation of great software.
Couldn't have said it better myself. Well, folks, that's a wrap on our deep dive into design patterns.
Thanks for having me. It's been fun.
It's been awesome having you here. Until next time, keep those designs clean, flexible, and always open to change. Happy coding, everyone.